Let's move to the fourth problem, which is, I think I will give this as homework. Okay, what is given here? An LTA system has LCCDE as given below. We have to find the impulse response of the system. So to find the impulse response, what do we want? We want the frequency response. So how do you get frequency response here? So taking Fourier transform on both sides and getting the common terms y of j omega by x of j omega, you should get this as the frequency response. What is that? 4 plus 5j omega divided by j omega whole square plus 7j omega plus 10. Okay, so what is the next step here? We have to factorize the denominator. You get 4 plus 5j omega. What are the factors? We can easily see that j omega plus 2 and j omega plus 5. So that is the factorization of the denominator of the frequency response. So what is the next step? Take the partial fraction expansion and take the inverse Fourier transform. You will get back your h of t. That is simple. I will leave it as homework. Let's go to the next problem, which is this. It says f of t is given, so we have to find the mean squared value. So what do you mean by mean squared value here? If you remember our first chapter, what is mean squared value? Mean squared value of a signal is nothing but its average power. Okay, so mean squared value is nothing but its average power. So because this is a periodic signal, what is the period for this signal here? So if you look at this a bit carefully, note that. So at minus 0.3 he is going up, and again he is going up at 3.7. So what is the total period? 3.7 minus of minus 0.3, which is 4 seconds, whatever, or 4 units. So a period of this signal is given by 4 units. So let us write down what is the mean squared value. So mean squared value is given by 1 by t integral from where to where we will take, so over a period t, okay, and modulus of x of t whole square dt. So this is the actual definition of mean squared value. Okay, so for us period is how much here? 1 by 4, and we should integrate over a period. So let us take that period from where to where? From this point. So from minus 0.3 to plus 3.7. So let us do the integration. So we will split the integral. So from minus 0.3 to plus 0.7, what is amplitude? It is 4. Okay, so that should be equal to minus 0.3 to 0.7. X square of t would be 4 square dt plus integral 0.7 to 2.7. The amplitude of the signal is minus 2 whole square dt, and 2.7 to 3.7 it is 0. So we will leave it like that. So this would be the average value or mean squared value of the given signal. So mean of squared value. Okay, so that should be equal to 1 by 4 multiplied with, so this is 16 into 0.7 minus of minus 0.3 is 1 plus, so this fellow is minus 2 whole square is 4 into 0.7 to 2.7 is 2. Okay, so that individual integrals will get evaluated to these values. Okay, so finally this is how much here? This is 16 plus 8, which is 24. 24 by 4 is 6. So mean squared value of the given signal, correct, turns out to be how much? 4. So mean squared value of the given periodic signal is 4. Okay, is that correct? 6, sorry. Mean squared value is 6. That is 6. Okay.